Hi, this is the first video for Chapter 13, which is all about product design and how many products you want to have, how many brands you want to have, thinking about product differentiation, both in terms of quality and in terms of horizontal differentiation. And this is obviously a really important question for firms, right? Firms spend a lot of time thinking about product design. So they're thinking about demand, what do customers want? They're thinking about technology, right? What can we actually produce? And then strategic considerations. So how is this going to affect our position in the market compared to our competitors? So we talked about two different kinds of differentiation in Chapter 7, right? Something like car color is horizontal. People have different preferences. Some people like to drive a white car for some reason. Whereas anything that everybody agrees on, we call quality, and we call that vertical differentiation. So everybody agrees that better quality is more preferable. So when scale economies are present, it might not make sense to offer an unlimited amount of variety, right? So if you think about car companies, they'll often offer cars in 4 or 5 colors, but they're not going to offer it in unlimited colors because it would be too expensive to do that. And then we've talked before about higher quality goods being more expensive to produce, right? In general, we're going to see actually an example later on where that's not always true. But in general, higher quality goods are more expensive to produce. And if they weren't, then they would just drive out the more expensive products because they would be lower quality. And then what we're also going to think about towards the end of the chapter is thinking about a portfolio of brands, right? So a product line. And we've already talked about this like with cereal, with cars, where you have lots of products covering a different variety, both of horizontal preference. So, lots of different types of cars and trucks and cereals made by the same company, but also vertical. So you're covering, everything from sort of the cheapest types of products to the most expensive types of products. And that may also have to do with both consumer preferences, technological constraints, and strategic reasons. So when a firm is trying to design a product, they have to think about, all right, well, how can I get the consumer what they want at the lowest cost for me, right? And so you have to think about, all right, well, what are the expected benefits of the product and what are the expected costs? And mostly what they'll do is saying, all right, well, what is the marginal benefit? How much can we increase sales? How much can we increase price if we add this characteristic? And then how much is it going to cost, right? And so they will adjust that until the marginal benefit of adding a certain characteristic is equal to the marginal cost in order to maximize profit. And so the first model we're going to do in this chapter is just a monopoly model where the monopolist is trying to choose the level of quality. And it's a really simple model, and hopefully you're sort of seeing how these models work now, where we sort of start with our common demand function and cost function, and we add something. So in this case, we're adding a Z factor, which is the quality. And so you can see our inverse demand now is P equals A minus BQ plus DZ. So price is going to go up as quality goes up. And so Z is our quality factor, and D is that coefficient in front of quality. And then our cost is just CQ, right? So that's our standard, fixed marginal cost model plus EZ squared. And so the idea here, as we said previously, is that quality costs more to produce. And so we're getting an increase in quality. And so 2EZ is going to be our marginal cost of adding quality. So this is kind of a nice model. We get an increase in quality causes demand to increase. Shift up without affecting the slope of demand. And so it makes it pretty easy to solve. And so really what we're going to do is we're going to think about, okay, profits, total revenue minus total costs. That's just going to be price times quantity. That's this here, minus cost. And we're just going to take the derivative with respect to both of our choice variables. So our choice variables here are Q for quantity and Z for quality. And so if we take the derivative with respect to quantity, we get A minus 2BQ, that remember the 2 comes down, plus DZ minus C, right? That EZ squared term that's got no Q in it, so it doesn't show up in this formula. So that equals 0. That's our first order condition. And then the derivative of profit with respect to z equals dq minus 2ez equals 0. So now we have two equations and two unknowns. Remember, a, b, c, and d are all just constants, and e. And so we can solve these pretty easily. So what we're going to do first is we're going to just look at our two first-order conditions separately. So first we have our first-order condition with respect to quantity. And so this is pretty standard, right? This looks very standard, except we've got these z factors. So in the graph, we've just set b equals 1. And you can see the vertical intercept here is a plus dz. So that's going to increase as d increases, right? So as people want more quality, they're going to be willing to pay more. That demand curve and the marginal revenue curve are going to shift up. And then similarly, right, the horizontal intercept for the marginal revenue is a plus dz over 2. And for demand is a plus dz. So as people like more quality, as little d increases, we're going to shift out. So this is basically saying the increase in the marginal effectiveness of quality, that lowercase d, causes demand and marginal revenue to increase. And so then firms are going to increase the output and the price for a fixed marginal cost in terms of quantity, right? Now, that doesn't have to do with quality yet. We need to look at the first order condition of quality. Remember, quality is z, right? And so here now our graph has z on the horizontal axis and dollars on the vertical axis. And we have an upward sloping marginal cost curve, right? It's 2ez. So it's just linear in z because we had a quadratic term in our cost function. And then marginal revenue is flat, right? So that's mrz. And so again, we're just going to equate marginal revenue, that's just the dq, right, from our revenue function, to marginal cost. And so we will produce at some level of quality here at z1 star at point A. And then if d increases, right, meaning people like quality more, and we get a shift up in that marginal revenue curve to mrz prime and dq prime, then we'll produce at point B where we have a higher level of quality. Similarly, you know, if E changes, right? And so E, remember, is that cost parameter for quality. So if it gets cheaper to produce quality, then the marginal cost curve will shift, and not so much shift as rotate down, and we'll produce at point C and we'll have more quality as well. And so those, either if people want more quality and are willing to pay for it, or if quality gets cheaper, then we're going to produce more quality. So that's not too surprising there. So just wrapping up this model, there's basically two results, right? The optimal level of quality increases as the marginal effectiveness of quality increases. That's that taste for quality, D. And it increases as the marginal cost of quality falls. That's the E. And so we solve for the equilibrium here. We're assuming that B equals 1 and C equals 0 just to keep the algebra a little bit more straightforward. And we can see that, you know, the firm will increase quality and earn higher profits as the marginal benefit of quality increases, as D increases, and the marginal cost of quality decreases, right, E. So if E decreases, profits will go up. So it's a nice little model. I don't think there's anything too surprising in its conclusions, but basically we're saying, you know, as people want quality, firms will produce more of it, and as it gets cheaper to produce, firms will produce more of it.